Okay, so welcome everyone officially to another session of the Cairo Bootcamp. So today we're going to be having Casweeney. He's going to be taking us through testing of Starknet contracts. I think the major update and everything has been given by Paul, right? But if you checked your email before now, you would have received the mail that says we're going to have a bonus session tomorrow, same time. And the bonus session is basically to help you guys if you have maybe questions. All the mentors are going to be on the call. If you have questions or probably you're struggling with your assignment or something, the goal of it is for you, all of you guys to like be able to finish well, right? So tomorrow's class will be by 6:30 West African time and 5:30 UTC. And for your previous assignment, if you did the assignment, can you thumbs up? Let me see if can you give a thumbs up? So nobody on this call has done the assignment. Nathaniel, let's see what's going on. When do you plan to do the assignment? Is there any issue that you are facing? Funny thing is your mentor is even on this call. So it seems nobody on the call has done the assignment yet. Well, tomorrow's call is for you guys. Come with all your questions, all the questions that you have concerning previous classes, assignments, and all. Your questions will be answered. The mentors will be around tomorrow. So I think, and then for the assignment for week 2, in the form that was sent to you guys were tasked to stop at modules, but it's just like left with Starknet. So if you can complete the Starknet challenges, it will be very good, right? It will be very good. So if you can complete it, please do. So I think that will be all. Any other announcements will be made after the class. So hi, Casweeney. So you have the floor. Thank you.
Hi, everyone. Can you hear me? All right. Okay, so it's good to be here. Good to see everyone. So today we'll be diving into testing on Starknet ecosystem, like testing both Cairo programs and Starknet smart contracts. So I will do my best to explain it, and everybody will understand the best possible way they can. All right, so without further ado, let me share my screen. The slide has my introduction, like introducing myself, so I will just be doing it with this slide. All right, here we go. Share the screen. Sorry. Please let me know if you can see my screen. Hello? All right, nice. Okay. Let me change it to slideshow. Okay, so before I proceed, this session is going to be packed with a lot. Like, we're going to be testing like 4 different smart contracts, hopefully. So I'll be moving very fast with the presentation. So we'll be able to cover up writing tests for the 4 different smart contracts we'll be using. All right, so the session will be on testing Starknet contract. My name is Casweeney. On Twitter, I'm CodingCas. So yeah, Casweeney, software engineer, blockchain to be specific. This is how I like to be seen online. So those of you that have seen Squid Game, I'm one of the guys behind those faces on Squid Game. Yeah, so this is how I like to be seen online. So today's agenda, we'll be looking at what is testing, categories of testing, why testing is important, tools for testing on Starknet, and we'll be doing like a live coding session where, you know, they say enough talk, show me your code. So proof of work. Then we are going to see how to test Cairo programs. We'll test a setter getter function or an addition contract, any one of the two. We are going to test an ERC20 contract, and we are also going to test a bar contract, then the assignment. So the reason why it's arranged like this is we are going to start from the most basic testing, and we increase the complexity gradually, like smaller, followed by the next one, and all of that till we get to the one that's more complex. So we'll be able to follow suit and understand how to test. All right, so we are in section 1. Sorry, before I proceed, hope I'm not too fast. I don't know, I can't see the meeting, so I'm on the slide at the moment. So if maybe there is any question, maybe, or you want to respond, I think someone should just unmute and speak, because I can't see the meeting tab anymore. Okay, so we are in section 1. What is testing? So testing is the process of evaluating a system or its components to determine whether it meets specified requirements or expectations. So the main goal of testing are to identify defects, verify functionality, and assess the overall quality of a system. So one of the reasons why you write tests is, okay, we have not gotten to why test, but yeah, this basically is telling us why you write tests. So testing is basically testing what you've built. It's not generally associated to smart contract. This testing in general. So it's testing a system, testing something to ensure that it meets required expectations and all. So moving over to categories of testing. So these are the categories of testing. We have unit testing, we have integration testing, end-to-end testing, force testing, and fork testing. Fork testing and is like a subset of integration testing. So it's also integration testing, but in a particular way. So let's look at unit testing. So unit testing involves, like, you know, when you build, when you write your code, right, you have a code base that is made up of a lot of functions. Unit testing is when you're testing a particular function. So let's say you have 5 functions, and you're testing this function individually, one after the other. Or sometimes you might be testing a part of the function. For instance, let's say you write a function that is to transfer money from someone to another person, and you want to test that transfer function. Now, writing a test for the transfer function alone is unit test. And also you can test something inside that inside the transfer function. For instance, you want to, you know, inside your transfer function, you need to check if the person that is making the transfer has the money they want to transfer. So you can test for that assert function inside the transfer function. So unit test is like you testing like one function inside your entire smart contract, or testing one component inside your entire system. That is unit test. So it's very focused and specific. Typically test one piece of functionality. It's fast to run because you're not like testing a lot of functions all together. It's just one component you're testing. So it's faster to run when you're running your test. It helps you locate issues quickly. Yeah, because if you're testing a particular function, you know that if that function, unlike integration test that you test a lot of functions together. So tracing the actual place where an error is coming from might be hard. So Since it involves testing individual function and its components, usually more because it constitutes the highest number of tests in your code. So this is actually true. So like I said, if you're testing a transfer function, you first of all test the function in itself. You can test the assertions inside the function. You can also test for the events that are emitted from that function. Sorry if this whole if this whole stuff I'm calling, they are sounding big, don't worry, we'll see the code and we'll understand better. So that's that about unit testing. And moving over to integration test. So integration test multiple components working together. So this involves multiple smart contracts sometimes. So let's say your building is taking smart contracts, and you know if you want to test your stake function, and you know your stake function is going to actually make use of an ERC20 token, which means you're going to first deploy your ERC20 token and approve that stake contract to use your ERC20 token before you now test the stake function. So which means in one test, you're interacting with an ERC20 contract, and at the same time, you're interacting with your staking contract. So integration test is not you testing one function. It's like you using multiple functions that depends on each other, or multiple contracts that depends on each other to write your test. And also, integration tests can involve you mocking, because we are going to look at mock testing. It involves you mocking someone. For instance, you want to, let's say, when you're writing your test, you initiate a call in your test. You don't know who is making the call. So you can create an address and you mock that address to act as if that address is the one making that call. So you'll be able to get some result or required outcome doing such kind of tests. We are going to see them in action today. And integration testing have fewer tests because by the time you've already combined so many functions in one test suite, you don't need to rewrite those tests again. For instance, if I am going to test my staking function, which means before I stake, I'll first of all mint ERC20 token to the account I want to use in testing. I don't need to go and start testing mint again, because if I'm able to use mint inside my testing while I was testing stake, it means the mint is already working. So there's no point going to test mint exclusively anymore. So verify interaction between different parts of the system. Like I said, you can interact with your ERC20 token to also test your staking contract. It's slower to run because it deals with a lot of moving parts, a lot of components. So most times when you run your test using Scap, it might take a while for it to run the test because it's interacting with multiple components and multiple functions and smart contracts. Integration test also represents real life scenario. Reason is because if you want to stake in a contract, you need to first, when you click that stake function, your wallet will pop up for you to approve the transaction. Like you're approving that contract should spend your token on your behalf. Once you approve that, you can now stake. Similarly, if you're writing integration tests, you have to perform all those use cases, all those steps that you would do normally as a user. So it represents real world usage more closely. Sorry, hope I'm not too fast. Hope I'm not too fast. Sorry. Let me just take this guy here. All right. Okay. Yeah, slideshow. Okay. Moving over to end-to-end test. So end-to-end test involves you testing the entire application. It is more focused on the UI. What we'll be doing on this call, on this whole session is about smart contract. But we don't have to omit end-to-end testing because it's also a category of testing. It's more of testing the UI, how the UI integrates with your smart contract and how the whole process works. It's not just smart contract specific. So it's like general application testing and all. So, and it's slower and more complex to set up because it's not just smart contract. It has to do with your front end, how it integrates with your smart contract, and how everything works. So we'll be looking at force testing. Force testing, this is one of the benefits, one of the tools that Foundry came with and all. So for those of you that maybe have written smart contracts with Solidity and Hard Hat, there's no force testing in Hard Hat. It's only available in Foundry and Starknet Foundry. So one of the main reasons of force testing is specifically designed to find breaking points in your code. For instance, let's say in one of your functions, you're accepting uint 16, right? And you want to test to be sure that if the number being passed, if the value being passed to this function is actually more than uint 16, you want to see what will happen. So these are kind of areas where you make use of force testing. Force testing, what it does, it will generate random numbers and pass it to the function that you want to force test. And once the number is generating exceeds the type, for instance, we have uint 16, uint 8, and uint 256. So if your function is accepting uint 8 and force testing is passing a uint that is of value of 256, that function is expected to break. So that is what force testing does. Basically, it's like looking for breaking points in your functions. So if you're writing functions, sometimes you want to check if this function can break, and most times you expect it to break at certain points. So that's what force testing does. Then moving over to fork testing. So fork testing is a way whereby you create a clone, so it involves creating a duplicate or a fork of a live production-like environment for testing. So I'm thinking of a very good scenario to explain this. Let's say you're building a platform that accepts payments of any kind of cryptocurrency. For instance, you build a platform where users can pay for things using Brother, using Stack token, using any kind of ERC20 token that exists on Starknet. But the price on that platform is being displayed in USDC, right? But you are accepting any kind of token. Now, what your contract will do under the hood is that your contract is going to interact with a decentralized exchange to swap that token you're using to pay to the actual token that the platform accepts for payment, which is USDC, right? So if you write such kind of smart contract, how do you test it? Because those kind of testing requires you interacting with the actual smart contract that is on chain. So for you to make those kind of testing, you have to do a mainnet forking. You have to fork mainnet, which will create a clone or a duplicate of the on-chain contract, and you can interact with the contract directly inside your system, but it's not going to cause any change on the main contract. It's just giving you an instance of that on-chain contract in your system. Please, if you have question on this particular fork testing, note it down because I know it can be confusing. So it also allows developers to test changes without impacting the actual production system. Like I said, the testing you would do, it's creating a fork of the mainnet, but you're not actually changing anything on mainnet. So it mirrors the real world conditions as closely as possible. Fact, it's more comprehensive. So it's more comprehensive integration testing compared to just running tests on local environment. Yeah, so it's also, like I said, it's also under integration testing, but it's like a different part of integration testing that is mimicking what is on-chain live, not just what is in your local PC. It helps identify issues that may only arise in a real-world production-like setting before deployment. So I think this is the last category of testing before we move to the next session. All right. So please note your questions down, because before we start coding, I will give room for you guys to like ask questions before we start the live coding. So why test? So this is basically the reason why you should test your code. Number one, you identify and fix bugs. Yeah, there was this contract I was working on. While working on the contract, they have already deployed on testnet. So I was supposed to write a test for that contract, only to find out that there was a bug in one of the functions in the contract. So testing help you identify and fix bugs. It also helps you identify and resolve security vulnerability. Also, if you notice, I separated these two. Someone will ask, okay, identify and fix bugs, identify and resolve security vulnerabilities. Not all bugs are security vulnerability. There are some bugs that will just make user not to be able to use your smart contract, but they don't really have a security issue. But the ones that have security issues are the ones that can exploit your contract and people will move money. So anything that has to do with blockchain, like most things that has to do with blockchain, money is involved. So you need to test your smart contract, ranging from ERC20 token, NFTs, and all whatnot. It has to do with money. Blockchain has to do with money. So you need to be sure that your contract works as it should, else somebody will exploit it and move away with your funds. So verifies that the smart contract works as intended. Yeah, one of the reasons why you test is you write test to assert that what you're getting is equal to what you expected. So you should have an expectation of what your function should do before you test it. So verify that the contract works as intended. Ensure correctness and reliability of your smart contract. So if you test your contract, you can hit your chest and say, okay, this contract is reliable and all. That's why you verify it and can see your code on chain to actually see what you did and all. Then build confidence as a developer. So there's one thing I need you to understand. When you write smart contracts, and you build it, it feels really good. There's a different kind of feeling when your smart contract is building, which means it is compiling. But there's a total different feeling when you write your test and your tests are passing. The feeling you get when your tests are passing is more than the feeling you get when your code is compiling. Because you just see, all my tests are passing. It feels really good. It gives you confidence as a developer and you stay joyful. So you can earn your bragging right that yeah, you know how to write tests and all. So that's for why test. Now let's move to section 4, that's testing tools. Please, just to confirm again, hope I'm not too fast. I know I saw I was going to be fast on this, so we are able to cover everything we need to cover on the proof of work side. Hope I'm not too fast. All right, okay. So testing tools. All right, so for Starknet, one of the tools for writing tests is Starknet Foundry, and that's what we're going to be using on this call. And the reason why we use Starknet Foundry is because it contains a lot of testing cheat codes. You know, in the course of this session, you'll be seeing some testing cheat codes and all. So that makes testing like you know, there are certain things you want to do when you're writing tests. For instance, like prank a particular address, or on the Solidity side of things, they call it pranking. But here they call it mocking in Starknet. So you mock an address, and when you mock that address, when you call a function, it is that address that you've mocked that is calling that function. So Starknet Foundry gives you some out-of-the-box helper tools to handle all of this, to make your testing very seamless and automated. So that's why we are going to be using Starknet Foundry. And the command mostly for like interacting with Starknet Foundry is snforge. Yeah. So that's why you saw snforge in bracket. So here we go. This is the live coding proof of work time. So I'm going to be like highlighting how we are how we'll be tackling this whole proof of work stuff. So modus operandi, smart contract test. So the first thing we are going to do, like 000, the basic of the basic, that's ground level stuff. We are going to test a Cairo program. You know, I'm sure you know that there's a difference between Cairo program and Starknet smart contracts. Yeah. So Cairo program can be used to build things outside Starknet, but Starknet smart contracts are smart contract that runs on Starknet, that's on the Cairo VM and all. Sorry, on Starknet. All right, so 001, we are going to test a Cairo program. Sorry, 000, we are going to test a Cairo program. 001, we are going to test a basic smart contract. That's an increased level of complexity. 010, we are going to test the RS20, which is a must do or a must know for anyone that is building on the blockchain. Then, and lastly, we are going to test a bank contract. And this bank contract will help us understand how we can use an RS20 token to deposit into a bank. So we are going to be testing the deposit function that we really need to use the RS20 contract. So let's code. Before we start coding, please ask me questions based on it. So we are done with the theoretical part where we are explaining. We want to move into the practical part. So any question you can ask now before we proceed. Let me see. Okay, no question. All right. All right, I'm going to exit this guy. Okay. All right, Nathaniel, yeah, shoot.
Okay, yeah, sir. So I just wanted to know, sir, for the testing that we'll be doing, will you do all the 6 types of testing that you just listed out, or maybe you will just take one of it or something?
Okay, so for the tests that I'll be doing unit testing and integration testing. The integration testing won't cover force. We are not going to do force testing. We are not going to do fork testing, right? E to E test is out of the scope. I was just listing the categories of testing. So E to E test is out of the scope of this test. That has to do with front end and the contracts together. So just so that we fall within the range of time. But if you explore like fork testing and force testing and you encounter any issue, you can drop it on the TG group. That's the Starknet Africa Telegram group, and I'll be happy to help you out with it. How are you doing? Is that okay?
Yes, sir. Thank you, sir.
All right. So let's proceed. I'm going to minimize this guy. All right. So let me just create a folder here. Oh, sorry. Okay, let me create a folder here. So I'll create a folder here. I'll just call it Starknet Africa Bootcamp group. All right, so inside this folder, so the first thing I'm going to do, I'm going to create a project that has nothing to do with Foundry. It's just a basic Cairo program. So I'll come inside here, this folder I just created, and new folder, call it test_Cairo. Okay, no, let's not start with test. Let's call it Cairo_program. Yeah, that's just the name I want to call it. You can name it anything. So I'm going to open up my terminal here. And so just to be sure, I'm sure everybody has all the necessary Starknet tools all installed and set up, like Scarp, SN Foundry, SN Forge, you know. Okay, all right. So There are different ways to create a project, the Cairo project, but I basically like using Scab, what is it? Scab init. So Scab init name, and I'll just call it the same name of I named the folder. I'll call it Cairo program. All right, here we go. So here is going to ask me, is this visible enough? Just to be sure. Can you guys see this guy? All right. Sorry, I refer to many things as guy instead of calling the name. It might be best to call the name. Okay, Wahab said he can't see the guy, so let me increase the size. 1, 2, 3, 4, 5. All right. So can you see it now? All right. So I'm gonna. So you see, we have two options: Starknet Foundry default and Cairo test. So if you hit the Starknet Foundry, it's going to like scaffold a project, like a smart contract project for you. That's where you want to write smart contract. But when you use the Cairo test, you're just creating a basic Cairo program that is not like smart contract centric. So this thing that I increased is, sorry, let me do this again. This thing that I increased is messing up in my terminal. Just a moment. Terminate. All right. So I'm going to open this guy again. All right. Okay. So I'll increase it first. 1, 2, 3, 4, 5. Okay. So I'm going to say Scab init this guy, click on it. So it brought up these two options. So I'm going to use the second one because we don't want to work with a smart contract yet. We just want to test a basic program. So I'll click on it. So it has created the file, it scaffolded some files and all. So I'm going to open it with my VS Code. And here we go. So let me close this terminal. Yeah. And yeah. So now this is our project. Let me increase the size. 1, 2. I'm sure you can see this. Can you? If you can't, thumbs down. Okay, you can. All right. So now we are in this guy. This is like a scaffold of just a basic Cairo program. This is a Fibonacci sequence and all. So the first thing we are going to do, we are going to write a different function. So take note of how this looks. I don't need this fib here. We have removed it. So I don't need this guy here. But so let's just leave it. We'll still make use of it. So this is where we are going to write our test inside this test module. And you give it this attribute. This is an attribute, CFG test. It tells the Cairo compiler that whatever is in this module has to do with test. So when you run scap test or scap test, it's going to run everything inside this module. So this mod means this is a module. So, and the entry point is your main function, your main function. This is the entry point to this whole code and all. So this is not a smart contract. This is like a basic Cairo program. So we are going to create a function for test purposes. We are going to say public fn add. Now this is a function that's going to add two numbers and also want to like add, when you're adding something, you take left and right, just two numbers. We are going to say left will be, let's use usize. We can do usize. So the reason why we do usize, if we do u8, it means you cannot add any number that is more than the range of u8. So let's do usize, which means you can add any number. We can also do u256 and all. So let's just do u256 if we have that. Yeah. So let's do right. We are going to do right u256, and this is going to return AU256 as well. Yeah, I'm sure you should be familiar with this syntax already. You'll be writing Cairo contract. So this is just for testing. So now all we just need to do is we do left plus right, and we are good. Like, you know, if you want to return in Cairo, you don't make use of the semicolon, unless if you're making use of a semicolon, you have to add the return keyword here. Then you can use the semicolon. Once you do this, you can use semicolon. But I like the other syntax more. It's more straightforward. It's Cairo-centric. So this is this. Now, we are now going to call this our add function inside this main, so that this main will stop crying. If, as you can see, it's crying. This red squiggly lines. Squiggly. Oh, sorry. So let's do add. Add, and we want to do 8, 10, and we do this guy here. So why? This guy is telling us that it's supposed to return a uint32, but we are returning uint256 here, which means these types don't match. So I'm going to remove this here first and see, and let me change this to 256. Yeah, we good. So you see, you're returning 256 here, and this guy is supposed to return uint32, but this function is returning 256, which means the return type doesn't match. So that's why it was crying. Now let's write a simple test for this guy. So this function is outside the scope of this module. So before we use it, we have to bring it within this scope. So to bring it within this scope, we make use of the super keyword, and we get the function, right? And we're good. Wait, sorry, we make use of use here. Yeah. So that's how we bring the add function within the scope of the test module. Now, to now do our test, we create this guy, and we call it test. Now we go inside here. Now, test suit exists inside functions. Test suit exists inside functions. So for every test case you want to write, you have to create a function for that test. So I will say fn test addition, right? And I will do this guy and create a block for it. Now, what I'm going to do now is to say let's result be equal to add, and I'll say 10, 10. And if I say 10, 10, what am I expecting this thing to return? I expect it to return 20. That's why I say when you're testing, you want to be sure that your contract or your function are working as expected, which means you have an expectation and you want to test to be sure that this function is working the way you expect it to work. So I expect this guy to return 20 for me. So what I'm going to do is I'm going to say assert that result is equal to 20. Else I'll say addition failed. You can say anything here. Addition failed. So like this now, we are done with this test, this particular test. So let's quickly run this test and see what will happen. So to test this guy, we just do scarp tests. Let's see. Okay. And you see the test passed. So if you look at this place, it's telling you test Cairo program. This is what we are testing, test addition, which is this function name here. And it told you, okay, that means the test passed. Now let's confirm to see if this test will fail. Let's make 10, 11. So normally we expect this guy to be 21, but this is supposed to be 21, but we are checking that result is 20. So this test should fail. So if we run this guy, you see it has failed because 10 plus 11 is supposed to be 21, but we are equating it, we are asserting that 21 is equal to 20, which is not possible. That is as simple as ABC, the simplest test possible, right? So this is the first test we are going to do. Moving forward, we are going to be testing smart contract. So before we go, any question? That means everybody understood what I just did here. No, I talk very fast, kind of, so I need to be sure that everyone is following. All right. Okay, so this is the first one. Let's now close the guy. This is test one. So we are going to create another project. So what we are going to test next is a smart contract, but it's the most basic smart contract you will ever write. So like a one level complexity on top. So I'm going to say, let's test the setter getter. So I'll call it setter underscore getter. So here now I'm going to right click, open a terminal on this guy. I just want opening so many terminals for me. All right, so the terminal is opened on this folder. So I'm going to say scarp. Sorry, let me increase this stuff again before I type. So I'm going to say scarp. All right, scarp init. So I'll call this setter getter. Setter getter. So now here I won't be using Cairo test because now I want to deal with smart contract. I'm moving into Foundry now. So I'm going to use the first one, which is the Starknet Foundry. I'll click it and it's going to scaffold the project for me and I'll be good. I'm going to open this guy on VS Code. So let me close this guy. Yep. All right. So before we proceed, let's maximize this. 1, 2, 3. Oh, that's too big. Let's go to 2. Okay. So here now, you see that there's now Starknet Foundry.2ml, there's scarp.2ml and all. And you have a test folder which you can write your test. So this one now, you're going to write your test in a separate file, not within the file where you note your code and all. Then let's go to the source folder. The source folder is where we have our lib.cairo, which contains our smart contract. And as you can see, the way this code is structured is different from the way the other one we just tested is structured. So you see that here we have a Starknet interface and we have a module with an attribute Starknet contract that defines that everything inside here is a smart contract. And this interface is an interface that you're going to implement that ensures that you implement all the functions that exist in the interface and all. So in interface is used for 2 reasons. You use interface for smart contract implementation and use interface for interaction. That's when it comes to smart contract. So if you want to interact with a smart contract that has been deployed, you use interface for it. And when you want to implement a smart contract, you use interface to force you to implement the functions that exist in the interface. And for for Starknet, when you create an interface, the Cairo VM automatically generates a dispatcher for that interface, which enables you to interact with an instance of a deployed smart contract. Okay, with that said, we are going to be writing the setter getter contract. So first thing first, I'm going to change the name of this interface to be setter getter. So it's going to be setter getter. So you see that this guy is complaining already because we are implementing hello Starknet here. Meanwhile, we have changed it to setter getter. So this next thing we are going to do, I'm going to change the contract name. This mod, hello Starknet, is the name of the contract. So I'm going to change it to setter getter, right? Then the next thing, I'm going to call this setter getter implementation. Setter getter implementation. This IMPL, you can call it info. So this IMPL is the short form of implementation. All right. So now this setter getter of super, what the interface we want to implement is no longer IMPL, it's setter getter. So I'll just copy it and put it here. All right. So I'm going to play all of this. So I'll remove this and I'll remove this so that we start on a clean slate. A clean slate. So you follow me as we proceed. So this is a clean slate. The contract is clean. There's nothing in our storage yet. Let me just remove this guy. We don't need anything here in our storage. So you guys will follow. Now, a setter getter contract is basically going to do two things. Set something to the state, that's to the contract storage, and read something from the contract storage. So for us to set something to a contract storage, which means we need to create a storage that can be set. So this is our storage struct. What should we set to? What should we set? Let's set name. If we set name, no, let's not set name. Let's set number. Let's set number. I don't want it to be complex. Let's say number is equal to U256. Yeah, that's what we want to set. Now, so I've created a storage variable, name number of type U256. Now, I'm going to create a function in my interface, which will be implementing inside the contract implementation. So I'm going to call this fn set underscore number, and this set number is going to take a mutable reference. So I'm going to say ref self, mutable reference of self, and this is going to be T contract state, right? Comma. Now we want to set a number, which means we are supposed to pass in a number that we want to set to the state. So I'm going to take in number here, and it's going to be of type, because the number here is of type U256, so the type here too should be U256, and this is not returning anything, so we kill it there. So the next function we are supposed to get is the one that is supposed to read from the storage, which is to get number, and we'll say get underscore number. So this one is not mutating state; it's just reading from state. So we don't need a mutable reference of state. We just need a snapshot of the state. So we're going to say self into. This is what you use to declare a snapshot. This @ sign. For those of you that write Rust, in Rust you call it reference. So here it's called snapshot. So you do the @ sign and you say T contract state. Come on. T contract state. And this is not supposed to take any other argument, but it's supposed to return something. It's supposed to return a U256 because it's getting something from the storage. So it's supposed to return something, and we end it there. Now we have our two functions. Now let's implement it. All I'll do is I'll copy these two functions into this place, paste it here, indent. So what I'll do here, I open this guy, come down, come here, open this guy, come down. Then I'm going to remove the T from this guy and remove the T from this guy. Now we are good. This guy is complaining because it expects you to return a number, but you're not returning anything. To just disable that error so that you don't see it, you can just come here and put 9, and it will stop throwing that error. So now let's implement our set number. So to set number, we just need to do self is telling you this contract, this state. Dot with self, you can read anything inside your storage. Dot number, and what you have inside your storage, you can read and write on those stuff using either the read method or the write method. So I'm going to do dot write, and I'm going to pass in this number we are receiving here and end the statement, and we are good. That's all, as simple as ABC. So now on this other guy, we want to read from the storage. I'm going to remove this 9 so that it's going to show that error. So all I just need to do here, I'll say self dot number dot read, and we're good. We are not putting semicolon because we are returning something. Like I said before, if you're returning in Cairo, you don't need to put semicolon. But if you want to use the semicolon, like you like that other syntax from other programming language, then you can add the return keyword here, and this will also work. But I like the Cairo syntax. So like this, we are done with our contract. Contract looks good, but how am I sure that this contract looks good or this contract is perfect if I've not tested? That is where the testing comes in. So I'm going to move over here. I'll move over here. This is our contract. This is our test suite. So let's do this guy. So now, for you to test this contract, you need to first of all deploy the contract. I like using this this template that is here. So for you to test this contract, you need to first deploy this contract. And when you deploy, you're supposed to pass in the name of the contract, and the name you're passing to this deploy function should be the same with the name of the module, this setter getter. That is what you should pass here. So, and once you deploy this guy, you first declare. So deployment takes 2 steps. You declare, you get the contract class hash. Then using the class hash, you can now deploy the contract, right? And you return the contract address of that contract. That is what is just happening here. As simple as that. And because our contract doesn't have a constructor, any constructor function that takes in an argument, we don't need to pass. This is an empty array here. So let's just play around with the test. So what we want to test, we are going to test the set. We're going to test the set. So there's this test now. I'm thinking of how to, this set number. You cannot actually test set number without get number, because if you test this set number, how do you know that this number has been set without calling the get number? So in this case now, we are not doing unit testing. We are going to make use of integration testing, because we are making use of, we want to test set number using get number. So this is integration testing. But for unit testing, you're testing the function in itself. So when we start writing maybe the ERC20 contract, I'm going to show you guys how to do unit testing. But for here, we are going to do integration testing. The only way we can test this set number alone without depending on get number is if we are emitting an event here. If we are emitting an event here. So what we are now going to test is we are going to test and check if an event was emitted. In that case, we are not going to depend on get number to test set number. But I don't want us to play around events now. This is supposed to be like a 001 contract, very simple. So in the ERC20, we play around events, hopefully. Are you guys following? If you're following, please let me see some thumbs up. Okay. Oh, okay. All right, let's proceed. So now we want to test. So basically, you remember I said when you're doing integration test is small. Integration tests are not much. So in this one test now, we are going to test both the setter and the getter. But if we're going to do unit tests, we'll test setter separately and we'll test getter separately. So, and it's good to always name your test suite according to what you're testing, so it doesn't mislead people. So when you say, we'll call this test set number underscore get number. So we are testing both functions at the same time in this test suite. So I'm going to remove this guy. We don't need it. We don't need this guy. Yeah. So now remember that, okay, let me just do this guy. So test this guy and this guy. The name of our contract is setter getter. So I'll copy it and pass it here. So this is going to deploy the setter getter contract. Now remember I told you, I mentioned that you use interfaces for two things, for implementation and for interaction. But on Starknet, on Cairo, when you want to use interface for interaction, you make use of the interface dispatcher, which is automatically generated by the Cairo compiler. This guy is still making use of Hello Starknet dispatcher. Our interface is not Hello Starknet. So I'm going to get rid of this, so we don't need this save dispatcher trait. So what I need here is let me show you. We need let me pick it from here. We need the setter getter. So I'll say setter getter dispatcher. So I'll just Control D and paste it. So this is what we need. But these two guys have been imported from the same source. There's no point doing this line here again. So I can just do this here, do this, and do command this guy. Then I'll get rid of the second one, and we could. So this compiler sometimes misbehaves. And how I know it misbehaves is because this declare is supposed to be blue in color, but it's ash color. It means the compiler is misbehaving at the moment. So it is only when I run my test that I will know that we are doing the right thing. So I don't like calling this guy dispatcher because it's misleading. Imagine I'm interacting with like 3 smart contracts in one test. If I call it dispatcher, what will I call others? So I'll just call it setter getter contract. So I know that this is a setter getter contract. If I'm interacting with ERC20, I'll call it the name of that ERC20 token, so I know what I have on that variable. So, and what we need is the setter getter dispatcher here. So, and once we do this guy, the reason why you're using only contract address here is because this guy and this guy are the same name. For instance, if I call this setter underscore getter contract address, once I put contract address here, I'm going to put a colon and I'll put this guy here inside this place. But you know, because so this is it. This is the key and this is the value. But because we named this contract address, there's no point doing contract address and contract address again. That's why we just had only contract address here. So the reason why I'm explaining this, so that if you see in another person's test and you see only contract address, or you see where they made use of another name here, you'll be able to understand what is going on. Now, what we are testing is setter getter. So I'm going to do, so we have our contract instance, and with this instance, we can call all the functions that exist in our smart contract. So I'm going to do setter getter contract dot set number. You see why I said this compiler is misbehaving? Normally it's supposed to have brought out the suggestion for me. Dot set number, and I want to set 20 there. Now I've set 20. So after setting, let me now get, and I'll say let's what I'm thinking of. See, one of the hardest things for dev is thinking of variable names. Let's contract number here. Let's call it contract number. Let's contract number. Let contract number be equal to setter getter dot get number. Yes. So this is where we have got, what is this? Okay, yeah, this is where we got our number. So let's just assert. So I'm going to remove these guys. We don't need this guy. We don't need this guy too. So just remove all of this. So we are going to assert that contract number is equal to our expected outcome. What is our expected outcome? 20. So it's equal to 20. And our message should always be in line with, like, it should describe what we are testing. Invalid. We just say, set number failed, because it's actually set number that failed. If the set number did fail, get number will get the right thing. So let's test this contract. So now this is, let me show you something. So let me open my terminal. On this guy, you can do sn forge test. I've not used this command before though. This is the first time I'm using it ever. So let's test sn forge test and run this test. Compiling. Please. Okay, let's see what's happening. So it said Star Africa base. What is it saying? Variable or constant found module. Wait. Which error is this? Ew. Okay. Where is this coming from? On line 12. Line 12. Test contract line 12. Okay. Let's see. Line 12. Ah, what is happening? Okay. We passed this guy. Which kind of, let me quickly close this stuff. So I'm going to close this VS Code and open it back. Maybe this compiler will have mercy on me. Oh, shit. Oh, okay. Yeah. Let's go back there. Okay. All right, let's see if the compiler is happy. Yes, it's happy. You can see that the declare is now blue. All right, let's see where we are getting the problem. Oh, this is it. Setter getter contract. We're supposed to call this. Are you guys seeing how helpful this is? So, yeah, nice. All right, so let's run our test again. All right, this guy has passed, and that's just it. As simple as ABC. So why I said I don't make use of this sn forge test command is because if you look at SCAB, you see that there's a script called test, and this test is calling SN Forge test under the hood. So what I normally use is scab test because it still calls SN Forge test here. So I'll just do this and it will still run my test for me. That's what I use all the time. Yeah. So this is yeah, so this works. Are we good? Any question before we proceed? Please shoot your questions before we move. Okay, I still have time. Okay. Any question? Yeah, all right, let's go, Nathaniel.
Okay, yeah. So my question is in the aspect where you say we need to deploy the contract. Yeah, before the testing, right?
Yeah.
So can you put more light in that aspect? Because I'm still trying to see how the deployment works.
Oh, okay. So
And what is yes.
it's not like it's a smart contract. So it's not like you're deploying it on mainnet or testnet. It's just like you're deploying it on your local VM, like your local, there's the VM, they hold this thing on your system that Starknet Foundry provided. You can declare and deploy your contract so that you get an instance. It is when you deploy the contract, you now use the instance of that contract to interact with it. Just like you cannot interact with, I don't know if I should be talking about Solidity, but just to give you an example of how this thing works. If you write your Solidity code on Remix, it's on Remix. You know you cannot interact with it on Remix unless you deploy it. Remix will now expose the contract functions for you. So similarly over here, before the contract functions will be exposed for you to actually call it and interact with it, you need to deploy it so that you get an instance of the contract. Does that make sense?
Yeah, yes, sir.
All right. Okay. So this is please, I need questions. If you don't understand, just shoot your questions. So
Okay. Yes, sir. And the structuring that you did there, can you explain the importation, please? You can explain it again. That contract class trace, I understand that is the interface we're importing, but
okay.
those declare result trade, I don't know where they are coming from. Those other parts, I don't really know where some of them are coming from.
Okay, so you know, on the Starknet ecosystem, before you deploy a function, sorry, I say function, before you deploy a contract, you need to first declare that contract. When you declare it, you get the class hash. Then using the class hash, you now deploy the contract. Now, for you to do all those things, there's what we call syscall. Syscall basically short name for system call. They call them syscall. There's a declare syscall and all. So normally, you're supposed to write that, you're supposed to use a syscall to declare the contract before you deploy it. But like I said, that Starknet Foundry out of the box has given you some sweet tools that you won't need to go through the rigorous process of doing your stuff yourself. And for you to make use of these tools, you have to import it from Starknet Foundry. That's why you see this SN Forge. This is a standard library. This STD represents standard library. So SN Forge standard library. You're getting this declare method, you're getting this contract class trait and this declare result trait. So trait is like, it's traits in Cairo and Rust generally enables you to create a shared behavior for different components. So with this declared trait, you can bring in some shared behaviors from the trait that you can use in declaring and deploying your smart contract. I don't know if that makes sense.
Makes sense, sir.
All right. Okay, let's proceed. So before we proceed, I will I'll just stop sharing my screen so that I can just do a quick setup, like for the next level of things we want to do. So just give me a moment. Yeah, I will be back in like a minute. Okay. All right. Meanwhile, for other persons that have not asked me question, please prepare your question. I love questions because they help me do deeper explanation on certain concepts that I might not have explained while teaching. So yeah. Okay. Hope it's not up to a minute. It's not up to a minute. No. This is not what I need. All right. Don't allow, please. And secondly, okay. Just a moment. Just a moment. All right, so I'm done. Coming back now. Just let me share my screen. Okay. Okay. All right. Sharing now. Entire screen. Here we go. Okay. So let me know when you can see my screen. And where is my camera? Can you guys see me? Can you hear me? Can you see my screen? I'm seeing just one thumbs up. 2. Please let me know if you can see my screen. 3, 4, 5. Okay. Let's proceed. All right. So now we are going to, let me see. So the next step we are supposed to do is the ERC20, right? That's the next level of complexity after the setter getter. Okay. So let's hit that. Now, before we proceed, there are 2 ways to write an ERC20 token. So ERC20 token is what powers the blockchain, the DeFi ecosystem. All those tokens you guys trade, Uniswap, Avenue, Kubo, name all those tokens. They are all making use of the ERC20 standard. So that's what powers the DeFi ecosystem. And there are 2 ways to create ERC20 tokens. You either write the ERC20 token from scratch yourself, or you make use of an already written contract. So on Starknet, there is these guys called OpenZeppelin. They help you create ready-made contract using a particular standard. So with OpenZeppelin, we are going to be making use of components. So component is like contracts that already exist that you can import in your contract. You don't need to write the entire thing from scratch. So that's what components are basically. So we won't be writing the entire ERC20 token from scratch. We just import a component from OpenZeppelin and use it in our contract. So we don't waste a lot of time writing smart contract when the focus of the session is test. Okay. With that said, I'm going to say ERC20. And as usual. Okay, let me just show you the second way to scaffold a project. Let me delete this. I've been using the other pattern for so long. Let me show you the second way. So I'm going to open my terminal on this Starknet Cairo Bootcamp folder. And when I open it here, I'm going to say scab new. You see, the other one was scab init --name. But this one I'm going to say scab new. I'm going to call it ERC20. So this one will create the folder and at the same time it's going to scaffold all the files that you need. So I'll do this. It still brings those options for me and I'll still use Starknet Foundry. So I've shown you the second way to scaffold the project and the other one. So I'm going to close this terminal and I'll enter this folder and I'll open this with VS Code. And this is gonna be code dot. All right, here we go. Okay, so I'll close this guy. Now, please, guys, this is about to start getting a little bit complex. So I'll really appreciate you guys to pay close attention because we have gone out of the 000 and 001. So now we are in a different level of complexity. Okay, so let's proceed. Let me maximize this 1, 2. How do we start? So you know all of this. What we are going to start with is this guy. Now, same thing. This is the whole, this is like a dummy contract. We want to create a token. And this token we are going to create will be using OpenZeppelin. So the first thing we need to do is what should we name our token? Let me look for someone's name here. I think we are going to name Nathaniel has been asking a lot of questions. He's still on this call. Let's name our token Nathaniel. Okay, let's call it Nat token. Yeah, that works. So he has been asking a lot of questions. So let's just do that. So we'll call this Nat token. So this is gonna be the name of our token. So I'm gonna pick this and I'll name the contract NAT token. And this is going to be NAT token implementation. Here we go. So, and this is gonna be implementing this guy. Yeah, this is what is going to be implementing. Okay, we're good. Now, first of all, we don't need all these functions here because what we want to do is import token from OpenZeppelin. So we don't need all those functions and we don't need the storage. So I'm keeping my contract as clean as possible. So this is my contract, right? So since we are going to be using OpenZeppelin component, we need to bring in OpenZeppelin into our contract. So how do we do that? I'm going to copy it and add it inside our scab.toml file. Scab.toml file. So if I come here under the dependencies, I'm going to put OpenZeppelin there. So now with this, we have everything inside the OpenZeppelin package in our system. This is from GitHub. If you visit this link, now it's going to take you to OpenZeppelin GitHub where you see all their packages, right? So we have imported OpenZeppelin here, and I've saved it. I'll close this scrap.html file. And also, let me just talk about this. So here is where you specify the version of OpenZeppelin you want, and the version can be gotten from their release. So when you go to their GitHub, you see their release version. I'm using 0.17.0 because I've used it a lot and I'm comfortable with it. I don't want to use their latest version. I don't know some changes that they did, and I don't want the error. I don't want to encounter the error in this session. All right. So now that we have imported that guy, then we have installed OpenZeppelin. The next thing we are going to do is to import OpenZeppelin component inside our contract. So this is how you use component basically. So I'm going to say use OpenZeppelin. I was waiting for this OpenZeppelin, and you're going to say : it should bring up something for me, please. Help me. It should be this compiler is token. Let's go. And it's supposed to bring, these are all the guys inside the tokens folder. So we need BRC20, and please bring up the suggestion. This guy. This thing is not okay. Let's say ERC20 components, and also ERC20 hooks empty implementation. This guy is late. Okay, so we have our component. In your last class, Mulini taught you guys how to make use of components in smart contract. So that's the same thing we are doing here. So we bring this guy in. Now that we have imported our component, to use a component, you have to make use of the component macro. So I don't want to go into explaining components, but to use a component, you have to make use of the component macro. And that component macro takes in three arguments. So I'm going to write this component here, and I'm going to enter so that it's going to bring out the 3 arguments for us. Now, the first argument is the path. Normally, the path is supposed to be all of this, like to the component path. But since we have already declared this, we don't need to redo it again. Remember, one of the fundamentals of programming is dry. Do not repeat yourself. So there's no point repeating ourselves. So I'm just going to click on this, copy it, and pass it here. That's one. Now, the second thing we are going to do is we are going to specify the storage. Now, the reason why you're specifying storage, remember that a component has its own storage and it has its own events. But you're bringing it inside your contract. The only way you can access the storage of your components inside your smart contract is to link the both storage together. And that is what we are going to do next. So we are going to say, inside here, we are going to do, and when you want to link storage in the component, you make use of an attribute called sub-storage. So you're going to say sub-storage, and it's going to be in bracket V0. And here now, it is advisable to name your storage, the name of the component. So we are going to call it, but in lower letters. So I'm going to say ERC20 into this guy now. This ERC20 component I'll pick it here. ERC20 component : I should get the storage from here. My compiler should be fast. It's taking a lot of time. So now once you do this, what you're going to do is to now carry this storage that you declare here and put it. So with this, you have linked your contract storage with the component storage. So you can access everything inside this component from your contract. The next thing you're going to do is to link the event. You know, you need to get the event from your component because component has events too. So first thing first, you're going to create your event enum. So you're going to say, sorry, this thing is too close. Let me give it space. They call it let your code breathe. You don't write codes that are too jam. You need to let your code breathe. So you come over here and you say enum, you call it events, your event enum. And inside this enum, you're going to, so any event you're getting from your component, you have to mark it with the flat attributes. And you're going to call it, so events are supposed to have this guy, call it event. So that's what tells your smart contract that this enum is for an event, right? And also you're supposed to do this here. You're supposed to say derive into drop, and you call this Starknet event. So this is how you create an event in Cairo. So here now you are going to call this ERC20 events. And once you do this, you get this component again, and you attach the component event : event here. Yeah. So that's it. Why is this guy throwing error now? This compiler. So once you do this, you pick this event here and you link it with this guy here. This should work. Please, I need this green squiggly lines to leave my. Why am I getting this error? What's happening? Why? There's 20 events. What's happening? My compiler is doing what I don't understand. Contract. Okay, has multiple implementation. Can you imagine? You see, this thing can be misleading. So this is me thinking I've done something wrong. Meanwhile, the compiler is taking a while. Sorry, my system is not that fast. Okay. All right, so let's proceed. Now we have this guy here. So the next thing we are going to do is to now actually do the implementation. So what we just did is we are just doing attachment. We are attaching the component to our contract. We are done with the attachment. Now we want to do the implementation so that the functions in the components we are importing will be visible in our contract. So that is what we are going to do next. So the next thing we are going to do is to say implement ERC20 implementation. That is what this thing means. ERC20 input is equal to ERC20 components, which is the guy colon ERC20. You see, it has given you all the available embeddables. We only talked about embeddables in the last session. So these are all the embeddables you can embed. You see, ERC20 camel case, camel only, and all. So I like using the ERC20 mixing implementation. I'll show you why. So let me quickly do this. Let me do the ERC20 implementation. Now, once you do ERC20 implementation, I didn't pass the contract state. Contract state here. Contract state, yes. So when you do ERC20 implementation, this only has the transfer from, the transfer, the approve, the allowance functions, all in snake case. For those of you, all in snake case, let me write it in the chat. All in snake case. Snake. This is snake case, all in snake case. So it has it in snake case. But now, your decentralized applications on the Starknet ecosystem doesn't use snake case to read from your smart contract. They use camel case, and this is camel case. I've written it. This is camel case. So that mixing implementation has both snake case and camel case functions. So if you see the transfer from that is snake case, it also has transfer from that is camel case. That is why I like using it. And also, there is a metadata embeddable that returns the name, symbol, and decimal. But the mixing has it too. So instead of importing them one after the other, it's just better I use mixing that has everything in it. So that is why I like using mixing. So if I do this now, sorry, let me do this. Let me just use mixing. There's no point doing that again. So I'll just say ERC 20 mixing. What is this? What is this? What is wrong with this one? Sorry, 1, 2. Give me this suggestion. This compiler has started ERC. This is it. So this is the mixing implementation we need. So you're going to pass your contract state into it. Contract state into it, and here we go. So with this, we have all the functions that we need from our component. But now this component is not visible to external public. The functions are not visible to the external public. All we just need to do is add this guy into it. It looks like we are using this class to write contract instead of test. Let's proceed to the test. So before we proceed, we need another implementation. Let me just do that. I don't need to write it. We need another implementation that will give us access to some internal functions. So now we have all of this. But there's no how we can use our token if we can't mint to someone. So I'm going to create a mint function that will enable us to mint that token so we can test it. So I'll come here and say fn mint. And mint is supposed to take what? It's going to mutate state. So we'll go to say mutable reference of self. And this is going to be T contract. I'm sorry, I'll be a little bit fast. I've taken a lot of time on just this. So T contract state. And it's going to take in what address of the recipient. Recipient. And this is going to be contract address. Contract address is a type on Starknet, and it's going to take in amount as well because you need to mint a particular amount to someone. And this is 256. I just realized that I've spent a lot of time doing explanation. Sorry. So let's come here. Let's import this contract address type. So I'll say use Starknet. Starknet. Oh, Starknet, colon, contract address. Give it to me. Yes, let's go. So we have that type imported. Is that correct? Why the line? Why the line? Okay, we're good. So now you see that this guy is complaining because we have mint, okay, U256, yeah, U256. So we have this guy here, but we have not implemented it yet. So we need to implement that function. So I'm just going to say this guy inside here is going to open up, and we remove this T here. So all we just need to do, since the mint function is an internal function, so all we just need to do, like I said, this storage gives you access to all the function inside your component. I'll just do self.erc20.mint. There's a mint function available for us. Yes, .mint. So I'm going to close it. Then what mint needs is recipient. This guy, just pick it up from here. Recipient, comma, amount, and we're good. We are done with our contract. So it's now time to test. I just have 15 minutes. Oh my. Okay. This compiler should behave. Please. Compiler. Okay. I don't need to wait for the compiler. Let me just compile. So I'll do scab. Scab now. Scab build. So this should build. Yeah, it's working. Oh, what? Oh, okay. So you see that, yeah, this contract address we imported here is only for this guy. We need to import it here inside the contract too. So that will fix our issue. Just saw it. So let's do it again. Sorry, this takes time. So you see that now, this is what we're talking about when that integration testing takes time. You see that because we are making use of a component that is from OpenZeppelin, you see that it's taking a lot of time to compile. It's done compiling. So imagine how your test would be. Your test will take much more time and all. So this is the contract. We are good. So let's now go to our tests, which is here. I will be a bit fast with this test so that I'll be able to cover up. We might not do the bank contract testing. Okay. So similarly, I don't need to touch this deploy contract. Assuming we were passing constructor, I would have modified this contract so that there will be a constructor argument. Wait. I omitted something. We actually need a constructor argument because we have not set the name of our token and the symbol of our token. So we need a constructor argument actually. So let's go over here. I'll say constructor here. And under here, I'll create a function named constructor. And you do this. It's mutating state, so we have to make use of ref self. And this is going to take in contract. This is going to be of type contract state. And we are not taking any constructor argument unless, no. Let's not make it any more complex. So what we are just going to do here is, we are going to say self.erc20. There is a method called initializer in our component. It's available in the internal implementation in this one on line 37. So we are going to say initialize. Here we go. Open this guy to close it. So initializer takes in the token name and the token symbol. So we are going to call this NAT. Okay, NAT token. And the symbol is going to be NAT. Yeah. Why the error? Okay, good. We're good. So I'm not going to build again. Build takes time. If we have any error, the test will tell us. So I don't need these two guys. I'll take them out. I just need the name. I just need, oh, I see. Okay. There's a little bit of a problem. But let me check. Just checking. Okay. I know what to do. So we are going to create an interface for this. So the reason why is because, this interface only has mint, but we are going to interact with transfer from, approve, and all of that. So we need an interface that has both mint and transfer from. Else we are going to be using two different interfaces to interact with one contract, and that will be redundant. So I'll just create it inside the text here. So we won't be importing all this interface. I'll just remove this. I'll create my own personal interface here. So that interface, I'll just do this. I have an interface somewhere I can copy, so I don't need to go through all of that. So this is the interface. So you see this interface, we want to interact with total supply, balance of allowance, transfer from this. And these are the metadata functions and this means function. So you see all of them are in one interface. That's why I called it ERC20 combined. You can name it anything. So I called it this. Now our deploy guy is not doing anything special. There's no constructor argument and all. So the first step we are going to test our constructor. Remember, the constructor is what is setting the name of our token and the symbol. So we are going to test if the name of our token and all those guys are actually setting properly. Now, this is an example of unit test because we are testing only constructor. Does that make sense? If it makes sense, please thumbs up. Let me know if you're following. All right. So we are testing only constructor function. So let's do test constructor. Here we go. All right. So our test constructor, we need to first deploy our contract, and the name of our contract is NAT token. So pick it from here, come here, and we paste this guy here. Now, like I said, we can leave it like this. We can leave it as contract address. You get, because we are going to interact. Okay, it's only ERC20 token we are interacting with. So let's leave it as contract address. If we're working with staking contract or bank contract, we need to name those variables so that they specify the contract name. So we can leave it like this. But I'll call this NAT token contract. And what I'm using here, I am using So you see, I pasted this interface here. I'm sure the compiler should have already created a dispatcher for this. So I'll do ERC. Hey, this compiler should not do anything. ERC20 combined dispatcher, please. Dispatch. Okay. Hope no errors. Let me see. My compiler has gone off. So you see this guy. Okay, let's just continue. We'll see the error if there is. So the contract address. Now to test our constructor, let's do let's token name be equal to this guy dot name. There's a name function inside that guy. So we duplicate this and we call this token symbol is equals to this guy dot symbol. What is happening here? Why am I getting error? This guy dot symbol. Why? NAT token contract dot name. Wait, let me see my interface. Is there name? There's name now. There's name and there is symbol. Why? Missing semicolon where this compiler is high. So token symbol, token contract dot this guy. So all we just need to do is assert that token name is equal to, what is the name we passed here? Is equal to this guy. Where is it? Where's our constructor? It's equal to NAT token. So just copy it over to this guy. It's equal to NAT token. Or you say wrong token name. Wrong token name. I'm going to remove all of this. We don't need them. And I'm also going to remove all of this, control command down, remove all of this. So now we have this guy. Similarly, I'll just duplicate this assert, but here we are asserting that token symbol is equal to, our token symbol is NAT, right? NAT. See, so we call this wrong symbol. So let's run this test quickly. And what's time? Okay. Oh, just 4 minutes. Okay, let's do scab test. This is a moment of truth, actually, to know if what you did makes sense. Okay. I think the compiler is among the stuff that is taking our time. You know, I would have used 1 minute to do a lot of stuff. Okay. I'm not expecting a failure. Let's wait for it. Okay. Yeah, here we go. So I'm even scared of running this test again because it's going to take another time. But this is it. You see, the test is passing because we just tested our constructor. And you see the name of the test here is test constructor. Just to be sure if what we did is correct, let's change this. Let's remove this N from this guy and see. You know the name of our token is NAT token. Let's remove the N from the token and see if it will still pass. Run it again. It should be faster now. Oh, wow. Okay. It seems we might only test constructor. Yeah. But I'm sure with the way we went, the way you explained the so okay. Okay. Thank you. So this guy's taking a while. Guys, I'm sorry. Okay, so you see it's failing now because we remove N. I wanted to do the same thing for the symbol, but I don't think I'll do that so that we don't spend any more time checking the symbol. But you see that everything works. So it's just a minute to when this class is supposed to end. And I don't know. Hi, Sarah. Should we end it here or? Hello? Can you guys hear me? Hi, Sarah. Hi, Paul.
Yeah. Hi, Casweeney. So,
So
like how
I
many
was
minutes?
asking.
Like how
Sorry,
many
go
minutes
on.
more do you need to round up?
Okay. Maybe 30 minutes if that will be cool. So we'll just finish testing the S20 so we can deal with mock testing and or if
Yeah. I mean, let's do it.
all right. Okay, thank you. All right, guys. I'm sorry for the extended time, but let's proceed. All right. So yeah, we just tested the constructor, and this is unit testing, just one function. So let's move to the next guy. The next thing we want to test total supply. Now, total supply testing will be an integration test because for you to test the total supply, if you test total supply alone, it will just be zero. But for you to actually test total supply, you need to mint first, then assert that the total supply is equal to the number of tokens of minted. So that is what we are going to test next. Okay, so I'm just going to copy this guy, pick it up here. So go down here, put it here. So now we are testing total supply, total supply. Test total supply, total underscore supply. Yeah, here we go. So we need every other thing apart from this guy. Apart from this, we don't need to test these two again. We already done that. So what we want to do now is before you test, you're going to mint first. So there's a way you get like address on Starknet. So let me look for an address. Let me just get something. So I'm going to I will copy this guy and paste it here. So I'm going to call this guy. So this is token recipient. This is like, I'm just creating this address. This is like a dummy address. This guy is supposed to throw an error because I've not imported contract address here. So I will, okay. Oh, I have it here already. Oh, that's nice. So now this guy works. So this is the guy we want to mint this token to. So the next thing I'm going to do is I'm going to say, watch me. I'm going to say, this guy, remember we have a mint function dot mint. Let me create a variable here called mint amount. Let mint underscore amount be equal to, let me just do 1,000. Yeah, 1,000. Let me make this a U256. So I'll type it here U256. And I'm going to do underscore U256. This is just some sweet syntax on Cairo. This guy is supposed to, is it higher? Yes. So this is 1,000 actually, but I just added like making sure it conforms with the 256. So I'm going to mint to this address, and at the same time, I'm going to mint the mint amount. You see, in this test, I can test balance of in this test. I can test balance of in this particular test because if I mint to someone, I should be able to assert that the balance of that person has increased. So I can choose to do it inside this test, but because I don't want to combine all the tests in one place, let's just test for only total supply. So mint amount, and you kill this here. So now that you've done this, I can just say assert that this guy dot total underscore supply is equal to mint amount because that's the only amount we have minted. So I'll remove the second assert. Then just say wrong supply. This should work. Please, I don't want to run the test. Let me just run it. Let me just run it. So let's just run it. But that's in scarp test. Wrong supply, wrong supply. Mint amount. So this is an integration test because you see, we are making use of mint, but what we are testing is total supply. Yeah, we are not just testing one function. Oh, so while that guy is taking time, let's be implementing the other test. So the next test we are going to implement will be the balance of. We don't need to test mint again. I'm sure you guys know we don't need to test mint again. If you agree with me, thumbs up. If you don't, thumbs down. Hello, can you guys hear me? We already use mint inside the total supply now. Okay, let's just test mint. Okay, this guy passed. You can see. Let's test mint then. We already used mint inside this guy. It's the same thing basically. If we test mint, we cannot test mint in itself. The only way you can test mint is you use either total supply or you use balance of. Unless mint actually has an event that you can test for the event. Yes, but let's not just, it's like a more complex stuff. I want us to cover a lot of RC20 testing. You understand? So for this particular test to pass, it means the mint is working. So there's no need to write tests for mint exclusively again, because that's what I say. Integration tests are not much because you already tested all your functions in one test. So let's just test. I can test for balance of in this same test, but let's just test for balance of and see. Yeah. So test balance underscore off. So to test balance off is just the same process we did. All you just need to do is assert that balance of the token recipient, the person that you sent token, you minted to, is equal to the mint amount. And you just say wrong balance. As simple. You see, it's just replication. I can just copy this assert line and put it in that place, and I'll test the same function without actually needing to create a different test suite for it. I don't know if I'm sure you guys understand. So let's run this guy. Scrap test, balance of should work. Yeah. So the next thing we are going to test is we are going to test approve. So let me see the time. Okay, yeah, we are going to test approve. We are going to test transfer. So approve and transfer are complex test suites. So you have to pay some kind of extra added attention and write your questions down, because I know you might have questions if we are testing approve and transfer. So let's do that. Let's do that straight up. Let's wait for this guy to just pass. We have 12 minutes. No, is it 12 or 22? 22. Yeah, we have 22 minutes to go. All right. So let me just pick up this guy again. Why this? We're waiting for this guy to move. All right. So here we want to test for approve. All right. That guy passed. Let's test for approve. Test underscore approve. Yeah. So the approve function in ERS20 basically also, can we pass any hex values in between? Yeah. So you can remove, watch, I can do this. I can put 00000 here. You see, that works. Anything you put there is just like a way for you to get an address. So I can get like 3 different addresses from this. Just change the X value you get. So, wait. All right. So we are testing approve. So I was saying what approve function does is approve. The approve function, let's say I have ERC20 token and I want to approve somebody to spend those tokens on my behalf. That's what approve function does. For every smart contract interaction you do that has to move tokens from your wallet account into that smart contract, there's an approve function running in that contract. So you're approving the contract to spend this token on your behalf. Then the contract will now initiate a transfer from your account into the contract. We are not going to test transfer from. Well, should we? Let's see. Can we? Maybe we can. I don't know. So approve. We need this guy. We need this guy. We need mint. We need to mint first. So first of all, we need 2 contracts. I need something called an owner. I'll call this token owner. Token owner. And I'll change the hex here. I'll use like 00. So this is mint amount. And we want to mint to the token owner. See, so writing test requires you to understand how the smart contract works. If you don't understand how it works, you might not be able to set up your test. You understand? So whenever, and it's most people run from tests a lot. So if you know how to write tests, it's an added advantage for you as a smart contract developer. So you need to first understand the contract, then you know how to set up your test. So now we are going to mint to the owner. This is the owner. I'm going to mint to the owner. So I want to mint to token owner, not the token recipient this time. So we have minted to the owner. Now, the owner, we can do an assert here to ensure that nothing is failing. So I like doing this. So I know if anything is failing, I know where it's failing from. I can do this, assert here that the balance of the token owner is equal to mint amount. Once you do this, if it fails there. If you don't do this, this thing I just did. If you're testing a large, if your test case is big, if you're getting an error, you won't be able to trace it. But with this, you can trace where the error is coming from because you assert at every instance. So now we have our token recipient. Now the next thing we want to do, this token owner to approve this token recipient to spend a particular amount of token on his behalf. So the next thing we are going to do, we are going to say, let's approve amount be equal to 100 underscore U256. I don't really need to do this though, but let's just see. Let's see. You can still work without doing that, so you don't get confused. Yeah, well, just do U256 here. So we do let's approve amount. You know, minted amount is 1,000 and approve amount is 100, so we don't confuse it. And the person we want to approve is the token recipient. Now, how do we mimic that owner to be the one to initiate that approval? That is where mocking comes in. The mocking someone, you have to mock that person. And Starknet Foundry has already given us some sweet tools to do that. So there's something called, okay, we'll get it from here. There's something called start cheat caller. I can't remember. Let me check. Yeah, it's called start cheat caller address. Yeah, start cheat underscore caller underscore address. Now, anytime you're mocking somebody, it is always good that after you mock the person, you stop the mocking. If not, that mocking will affect another mocking you're doing. So this statement I just made, if you're confused, note it down, ask questions. So I'm going to say, pick this up, guy. So put this guy here, paste it. Then all I just need to do is change the start to stop. S-T-O-P, all right. So my compiler is not doing well. If not, this guy would have been blue. So let's go. Now, so let's mock test approve. So now we want to mock, we don't need mint again. This is mint, we don't need mint anymore. Yeah, we only need mint in the place. So the first thing we are going to do, we are going to say start cheat caller address. Now, the first thing you're going to do, you're going to pass in the contract address of the smart contract you want to interact with. So I'm going to get this guy, this contract address here, which is the token contract address. Then who do we want to mock? We want to mock owner, because owner is the one that has the token, right? We do this here. We end our statement. Now, inside here, now we are now going to say not token contract dot approve. Now, approve takes three. How many stuff does approve take? Approve takes two arguments: the person you're approving and the amount you're approving for that person. So we want to approve token recipients, right? And we are approving token recipient to spend this approved amount, right? We are done. The next thing we are going to do is we are going to stop this mocking here. And what we are going to do, we are going to pass in the contract address of the contract we want to stop the mocking on. Remember, it's stop mocking. So we are going to change this to stop, right? Now, how do we test to ensure that this person that we approve has actually been approved? There's another function called allowance. With allowance, you're able to know if someone has been approved by another person. So what we are going to do next is, in our assert, we are going to say assert that not token dot allowance. What does allowance take? Let's look at the interface. Allowance takes in the owner and the spender. So we are going to put in the address of the token owner here, comma, the address of the token receiver. Now, the amount is the approved amount, not the mint amount. Else, we are going to say wrong allowance. Let's test this. So let's hit test and see what's happening here. Are you guys following? Okay, mocking someone, it's like when you're writing smart contracts, just like this token, you minted token to an address. You know, I'm thinking of the best way to explain this so you don't get confused. So, you know, as we are now, we are different individuals. What is happening here? Okay, we are different individuals, and we have our individual accounts, our smart contract, our wallet accounts. Now, let's say someone meets, I have a token and I want to approve someone, right? On a normal case scenario, it is me initiating that transaction. But in our smart contract, we minted token to a particular address. How do we initiate an approved transaction using that address that we minted the token to? We have to mock that address and make sure that the address is the one calling the approve function. So that is what mocking means. Mocking is basically mimicking an address to perform an action. A smart contract, a call to a function in a smart contract. All right, thumbs up. So why are we getting error? Could not compile. It could not compile. Why? Let me see. Sorry, I need to close this so that my compiler will be able to help me close this guy and open it again, because that compiler is very, very much helpful. All right, cool. Aha. All right, so where are we getting the error? Okay, my compiler is active now. Where is the error coming from? I can't see any error here now. I think it's problem from the compiler. Scrap test. Let's see again. Oh, I can see something has been highlighted. Where? Okay, where is it? Where is it? Where is it? This is a red line. Let me maximize the stuff. Go. Aha. This is a red line. Where is it coming from? I can see it. Okay. Oh, I've seen it. I've seen it. Sorry. Yeah. So there's something here. Let me kill this process and start it again. I've seen it. Yeah, it's working now. Okay. Scrap tests. No errors anymore. So the next function we are going to test is a transfer function, and that will be the last function we'll be testing for the ERC20. We have just 9 minutes to go. We'll be able to test that function before time. So, yep. For me, why the compiler is playing around, let's start writing the test. So we are going to write test for transfer. The transfer test will look similar with the approve. So here we want to test for transfer. So similarly, we deploy, we mint to token owner and assert that the balance of token owner has increased. Then we call this, let's call this transfer amount, right? And we are transferring 100. Okay, let's say we're transferring 100. Okay, that test passed, so we are good. We are transferring 100, and we want to transfer to this guy. So what we want to do is the same stack chip caller. We are mocking. So on the Solidity side of things, they call this impersonation. In Solidity, you call it impersonation. You want to impersonate an address, but here we call it mocking. So we are mocking this guy to, we are mocking this contract for token owner. We are mocking token owner for this contract instead. So now we want to call the transfer function. So transfer, which means it is a token owner that is performing the transfer. And the token owner is transferring to token recipients this transfer amount. So we are going to stop cheat caller. Here now we want to assert that balance of the token recipient. Balance of, not balance, balance underscore of token recipient is equal to transfer amount. Else we are going to say wrong, let's call it. So this is failed. So you need to minimize the number of words you're passing in. Balance failed. I'm thinking of 2 words that will describe this thing. If you use balance increment, failed. Okay, that didn't throw an error. So the next thing we are going to check again, we need to actually be sure that the balance of the owner decreased, because this is a transfer. We are going to say this balance of token owner is equal to, it's equal to mint amount minus transfer amount. You remember now, we minted mint amount to this guy. So if we transfer, it should decrease transfer amount from the total mint amount, which is what the owner has. So you now say balance, just do incorrect balance. I think that should work. Incorrect balance. Yeah. Hope I didn't do any typo. Let me see if my compiler is active. Yes, it's active, so no typo. Okay, so with this, we are done testing the ERC20 because we have tested allowance, we have tested approve, we have tested mint, we have tested balance off, we have tested transfer. The only function we didn't test is transfer from. So transfer from needs you to approve first, then you transfer from, and we don't have much time. So I'm now gonna run my test again, and let's see what happens. So this is it. I don't know. Please, can this code be shared with us at the end? Yeah, sure. I can share it. Do you need the other? You know, we created 3 projects. I can share the other 3 with you, so we use it to study. Yeah. So you can be preparing your question. I think this is the last test we are writing. So if you have any question, we have like 4 minutes to go. You can shoot me those questions before time ends. And you can bring up your questions now while we wait for the compiler to finish if you have any. Hi guys. Are you guys with us? All right, our test cases are passing and we are good. So that is all for this session. I would have really loved for us to test the other contract, but there's not much time. Can you please share the code for the approval so we can? Yeah, I'll share everything. I'll share all the contract, the code, everything. I'll share. All right, that is all from my end. Yeah, Sarah.
All right. Yeah, thank you so much, Casweeney, for the insightful session. It was so great. Thank you. So guys, tomorrow we are going to be having the bonus session tomorrow by 5:30 UTC. Please try as much as possible to join the class. All the mentors will be around, so make sure you come with your questions and concerns, everything, please. And then the assignment form will be shared tomorrow, right? The assignment form and the feedback form. Try as much as possible to do your assignment, do the previous assignment. So it's only 4 persons that have submitted their pull request for the last class. So I don't know why you guys haven't submitted, but try as much as can to do your assignment and submit your assignment. And also for the tackling challenges, if you can finish the exercises, please do. Yeah, that would be very great. So I think that's all. Paul, is there any other announcement I'm missing out? Any other information?
No, I mean, this is the second to the last session. So we have, apart from the bonus session, we have like 1 more session to go. And I'm really looking forward to see everyone that has been following some of the assignments, so we can actually like have very good number of graduates from this Cairo Bootcamp. Also, I'm looking forward to meeting a few number of you in Lagos, like for the meetup, and also like in Nairobi. So if you'll be around then, we are looking forward to meet you by then. But first of most important thing is make sure you complete your assignment, and so we can have good number of graduates, and also like talk about it and also put everyone out there. I'm also looking at doing a community call whereby like everyone that graduated and even people that participated will come on the community call to talk about like the experience, and also like we will also talk about like opportunities in Starknet, like only those and a whole lot of other stuff. Or even if you want to like build your project, the available grants like seed grants, growth grants, and all those other stuff you can do after graduating from the bootcamp. So I'm really looking forward to next week, Thursday. But I'm targeting Friday next week for the community call though, but I haven't decided that yet. But I will communicate that. Apart from that, I don't have any action to add.
All right, thank you. Thank you guys. So I think we can call it a night from here. Good night, guys. See you tomorrow, 5:30 UTC. Bye.
Bye.
Bye, guys.
Bye.